Today's topic is on lattices and it is related to the discrete mathematics. So here are the few examples and we have to determine whether the posets represented by the Hasse diagram given below are lattices. And let's get started. So this is the first example. So here is the Hasse diagram and we have to consider any two elements and it should contain the greatest lower bound and the least upper bound for each and every pair. So if you consider 7 and 4, so here the greatest lower bound is 7 and the least upper bound is 4. So if you consider 3 and 6, so 3 is the greatest lower bound and 6 is the least upper bound here. If you consider 4 and 5, so 4 is the greatest lower bound and 5 is the least upper bound. If you consider 2 and 3, so 2 is the greatest lower bound and 3 is the least upper bound. So each and every pair has the greatest lower bound and the least upper bound. Hence we say that the given poset represented by the Hasse diagram is a lattice. So this is a lattice as it's containing greatest lower bound and the least upper bound. And the next question here is, see here, this is the Hasse diagram and if you consider any two elements, it should contain the greatest lower bound and the least upper bound. So for example, if I consider 3, 4, so if I consider 3, 4, here what is the least upper bound and the greatest lower bound? So here the least upper bound for 3 and 4 is nothing but 5. So this is nothing but 5. And here the lower bound, the greatest lower bound is here but for 2 and 4. So they meet at a point 2 as well as they meet at a point 1. So here if you observe, we are getting the greatest lower bounds. So there are two values here. So we say that the greatest lower bound does not exist. So it should be unique. So the least upper bound and the greatest lower bounds are unique for any pair of elements. So we say that the given poset represented by the Hasse diagram is not a lattice. So this is not a lattice. So this is not a lattice as it contains two greatest lower bounds. And next coming to this, see here there is a single top here. So this is represented by 2, 3, 6 and 12. 2 divides 6, 3 divides 6 and 6 divides 12. So there is a divisibility operation here, and if you observe, if you take any two elements and it should contain the greatest lower bound and the least upper bound here. So let us say if I consider 2, 3 here. So if I consider 2, 3, so what is the least upper bound and the greatest lower bound? So here for 2 and 3, the least upper bound here is 6. And when we consider the greatest lower bound of 2, 3, so it doesn't exist. So here it doesn't exist. So if it has no greatest lower bound or least upper bound, then we say that the given poset represented by the Hasse diagram is not a lattice. So this is not a lattice. And the next one coming to this, so here the set of elements 1, 2, 3 and 4. So here according to this Hasse diagram, if we consider each and every element, so if we consider 1 and 2, so 1 is the greatest lower bound, 2 is the least upper bound. If you consider 1 and 4, so 1 is the greatest lower bound and 4 is the least upper bound. If you consider 3 and 4, so 3 is the least upper bound and 4 is the greatest lower bound. If you consider 2 and 3, so 2 is the greatest lower bound and 3 is the least upper bound. Hence each pair has the greatest lower bound and the least upper bound. So it is a lattice. So the given Hasse diagram, so the posets represented by the Hasse diagram given is a lattice. And next coming to this, so here the Hasse diagram contains 0, 2, 3, 4 and 5. So if you consider any two elements here, so it should have the greatest lower bound and the least upper bound. So here if you consider 2, 3, so here 2, 3, so the greatest lower bound is 0 and the least upper bound is 5. If you consider 3, 4, so here the least upper bound is 5 and the greatest lower bound is 0. So if you consider 2, 4, so here the least the greatest lower bound is 0 and the least upper bound here is 5. So each and every pair of elements has the greatest lower bound and the least upper bound. Hence we say that this is a lattice. So here it is a lattice. And coming to this, the next Hasse diagram. So here we have the elements A, B, C, D, E and F. So if I consider the elements, so if I should consider any two elements here, so if I consider A comma B, so here if I consider A comma B elements, so here the least upper bound and the greatest lower bound should be calculated. What is the upper bound for A comma B? So it is a C. So this is C. And coming to the greatest lower bound, so it doesn't exist. So they does not exist. Doesn't exist. And next one, if we take EF, so if we consider E comma F, so what is the least upper bound and the greatest lower bound? So here the upper bound doesn't exist, so this does not exist. So this doesn't exist. And for E comma F, so here is the greatest lower bound, which is equal to D. So hence we have no greatest lower bound for A comma B and the least upper bound of E comma F doesn't exist. Then we say that this is not a lattice. So this is not a lattice, and this is so simple to understand. So for each and every element it should process, for each and every pair of elements it should process the greatest lower bound and the least upper bound. So hence the first Hasse diagram is lattice. The second one, as it's having two greatest lower bounds, so it is not a lattice and it has a single top. And here we have this one, the greatest lower bound of 2 comma 3 doesn't exist. So here the lower bound doesn't exist, therefore it is not a lattice. And here also each and every pair of elements has the greatest lower bound and the least upper bound, hence this is a lattice. And here coming to this, so each and every pair of elements has the greatest lower bound and the least upper bound, so this is a lattice. And coming to this, as we have no, here the least upper bound doesn't exist and here the greatest lower bound doesn't exist, therefore we say that this is not a lattice. And this is how we have to consider whether the given poset represented by the Hasse diagram are lattices or not. Hope you guys got an idea and you can calculate by yourself, and I'll be posting many more problems related to these series. Have a look at those. Please thank you so much.